Assalamualaikum warahmatullahi wabarakatuh. My name is NURUL SYAZWANY binti Muhammad RIDUWAN. My metric number is 1.2-02565. My group and I will present about rounding, significant figures, and decimal places. I will present the introduction of rounding, significant figures, and decimal places. Firstly, rounding. Rounding is used to simplify answers. When rounding, we are creating numbers that are approximate to their original value. Rounding gives us numbers that are easier to work with. First, we decide the numbers that we want to round. And then, if the next digit is less than 5, we don't have to change the number. And if the next digit is more than 5, we need to plus one of the numbers. The second one is significant figures. Significant figures are used to give us an answer to the appreciate precision. We use SF as acronym for significant figures. As example, 3SF is 37.7 Celsius. And the next one, if the numbers start with 0, we count the significant figures from the first non-zero number. The last one is decimal places. The number on the right, the decimal places is the number on the right to the decimal point. The correct number of decimal places is used to indicate the correct precision when adding or subtracting.
Assalamualaikum. Now let's move to the significant application of rounding, significant figures, and decimal places. Okay, the first one is rounding. Okay, rounding is essential to avoid expressing a value to a greater degree of precision with the uncertainty in the measurement, which means by using rounding, we can make the number much simpler and easier to use. Okay, next is decimal places. Decimal places is important to make sure that we have a more accurate value than just a round number. When we are doing an experiment in the lab and we have to measure a volume of a solution by using apparatus like burette or volumetric flask, the result has to be in decimal place in order to obtain a more accurate measurement. So that's how important the decimal place is. Lastly is significant figures. Okay, the first thing is significant figures important because it tells us where we need to round, so we don't have to worry whether we need to round into 1 decimal place or 2 decimal place or 3 decimal place. Secondly, the real importance of significant figures in chemistry is to make sure that the result of your calculation and measurement is precise, but not more precise than the number you start your calculation with. It's very important to apply when you are working in chemistry field. For example, let's say you are hired as a chemical technologist for a company that produces pharmaceutical product, and then in one project you have to separate a sample of 32.5 ml into 7 equal parts in 7 test tubes. So we use calculator to calculate how much the volume is. So 32.5 divided by 7, and the answer we get is 4.642857143 mil, a very long number. So you record your result you get in a report and hand it to the supervisor. But the supervisor said the measurement is inaccurate. So where is your fault? The fault is that the technologists think that the more digit you get, the more accurate the measurement is. But if we take a look at the starting number we start with, which is 32.5 mil, it's only precise to 3 significant number. So it doesn't make sense that with the result we get is a very long number, because reporting such a long number is like claiming a precision that cannot be true. So the answer should be 4.64 mil only. So that's how the importance of the significant figures in chemistry.
This question is about rounding. The question asks to round 1000.9953278 to 6 digits. But do remind that 6 digits doesn't mean 6 decimal places. These two have different meaning. For example, if the question asks to round to 6 decimal places, for example, I will write the question again, the numbers again. 9953278. The same decimal place, 6 decimal places. It will be not the 7 here, right? 1, 2, 3, 4, 5, 6. Then we will look at the number beside the 7, which is 8. So we round up this. So it will be 5328, right? But this is not what the question wants. Since the question asks for 6 digits, we will count from here. 1, 2, 3, 4, 5, 6. 9 here is the 6th digit. So we will look at the number beside the 9, which is 5. So we will have to round up. But since the 6th digit is 9, we will also round up the number here, which is also 9. And then we will have to round up 0 here. Round up. So the answer will be 1001.00. These two zeros also need to be written because the question wants 6 digits. So this will be the answer.
Assalamualaikum. My name is NURULFATHNIN and I will show you an example question related to the chemistry problems for this topic. The question gives us 0.0021 liter sample of fluorine gas heated from 22 degrees Celsius to 187 degrees Celsius at constant pressure. What is the final volume? Give your answer in 4 significant figures. Okay. The question already give us the initial volume, the initial temperature, and the final temperature with a constant pressure. From this question, we get a hint that this question will use a Charles law formula, which is V1 over T1 equal to V2 over T2. So we already got the number. Fill in the number to the formula. So 0.0021 over 295.115 equal to X over 460.15. So we will get the final volume 0.003274 liter. The question give us a specific instruction for to find the answer in 4 significant figures, and we will already get the answer. Since the 0 before the 3 is considered a leading 0, which is not considered as a significant figures. So we got the answer. But we can turn the decimal places to the scientific notation. However, we must alert to always maintain the same number of 4 significance. So we can change the number to 3.274 exponent negative 3 liters. Assalamualaikum. My name is NURULFATHNIN and we will discuss another question related to the chemistry problems for this topic. The question wants us to calculate the density of ammonia NH3 in grams per liter at 725 mmHg and 55 degrees Celsius. Give your answer in 3 significant figures. Okay, the question wants us to find the density, but did not give us the mass and the volume of ammonia. but already give us the pressure and the temperature. So the only option for us to solve the question is to use formula PV equal to nRT, also known as ideal gas equation. But since we also don't have the number of n, we can elaborate the n to mass over molar mass. Flip it around, change it around, we will get P molar mass of equal to density RT. We will need to use 0.08206 for R in order for us to get the final answer in grams per liter. And since we need to use that number, we need to change the pressure from 750 to mmHg to 0.9895 atm. So we already get the numbers. Fill in the numbers to the formula, and we will get the density is 0.62468. However, the question already give us a specific instruction to only have 3 significant figures. The first number is zero, but that is not considered a significant figures because it was a leading zero. So the first significant figures is 6, followed by 2, and followed by 4. However, the number after the 4 is 6, which is higher than 5. So we need to follow the rules of rounding. So the 4 is turned to 5. Since 6 is higher than 5. So the final answer is 0.625 gram per liter. Thank you.
Bismillahirrahmanirrahim. My name is NURULFATHNIN binti MUHAMAD YUSOF, and today I'm going to talk about decimal places. Okay. It says the correct number of decimal places is used to indicate the correct precision when adding or subtracting. Consider the number 4.5312, which is given to 4 decimal places. However, we could also write to this number to 1 decimal places, which will be 4.5. For an example, we can see at this example in the textbook. A baker is making a cake and adds to the mixture 100 gram of flour, 40.2 gram of sugar, and 40.134 gram of eggs. Calculate the total mass of the cake to the correct number of decimal places. So we just need to follow all what it says. So we just need to add everything, and it shows 100 plus 4.2 plus 50.134 gram equals to 190 and 334 gram. And we haven't finished yet. We need to round the decimal place to 1 decimal place, and it will be 190.3 gram. That's all.
Okay, so this is the last question. Okay, the question is electrolysis of molten magnesium chloride is the final production step in the isolation of magnesium from seawater by the Down process. Assuming that 35.6 grams of magnesium metal forms, how many moles of electrons are required? Give in 2 decimal places. Okay, so I will show how the calculation. Okay, so first we need to find the mole of magnesium. Okay, as we can see at the question, it gave the mass of magnesium metal. So it is 35.6 gram over the molar mass of magnesium chloride. So 35.6 gram over 24.3 gram per mole, we got 1.46502 mole. Okay, so we make the equation like that. Magnesium 2 plus 2 electron, we get solid magnesium. So 1 mole magnesium needs 2 mole. So the calculation is 1.46502 mole times 2 mole electron over 1 mole. We got 2.93004 mole. Okay, so we place it into two decimal places. So we conclude it as 2.93 mole. So the moles of electrons that required is 2.93 mole.